Circle Theorem 1. A tangent and a radius meet at 90 degrees. So the tangent is the line that just touches the circle and it meets the radius at 90 degrees. Circle Theorem 2. Two radii form an isosceles triangle. If you look, the two radii are going to be the same length. So you are going to get a nice isosceles triangle there where the two angles inside the isosceles triangle will be equal. Circle Theorem 3. The perpendicular bisector of a chord passes through the center of the circle. So first of all, it's good to know what a chord is. So a chord is a line that cuts the circle but is not the diameter. The perpendicular bisector is just referring to the line that goes from the center to the outside, so in other words, the radius. It will cut that chord exactly in half, hence the word bisector, and it will be perpendicular, so 90 degrees. Circle Theorem 4. The angle at the center of the circle is twice the angle at the circumference. So if you've got an angle x there on the circumference, then the angle at the center will be double it, 2x. Circle Theorem 5. The angle in a semicircle is 90 degrees. If you've got the diameter and then a triangle being formed in that semicircle, half the circle, that angle there is 90 degrees. Circle Theorem 6. Angles in the same segment are equal. So first of all, make sure you're happy with what a segment is. So we saw a chord earlier being a line that just cuts the circle that's not the diameter. That will cut the circle into two pieces. The big piece is called the major segment and the smaller piece is called the minor segment. Either way, if you then are looking at two angles in that same segment, they will be equal to each other. Circle Theorem 7. Opposite angles in a cyclic quadrilateral add up to 180 degrees. A cyclic quadrilateral is just a quadrilateral where all four corners touch the side of the circle. And as you can see here, the opposite angles, for example, A plus B, they'll add to 180, and so will C plus D, also add to 180. Circle Theorem 8. Tangents from the same point are the same length. So when you have two tangents coming from a point outside the circle, wherever they touch the circle, not only do they meet the radii at 90 degrees from the earlier circle theorem, but those two tangents are actually also the same length as each other. As you can see here, we get a shape which is a kite. It's a kite because those two lengths are the same, but also the two radii are the same. So you get a nice symmetrical quadrilateral kite. The last circle theorem or rule is called the alternate segment theorem. This one is usually the hardest to spot, but what I would recommend is look for any tangents that you have. And then also if you can see a triangle inside the circle touching that tangent. And then it's a case of looking at the angles and knowing that these two are the same. So x and x are the same and y would be the same. I find with this one, it's more about spotting the pattern of what's equal and then remembering it's called the alternate segment theorem. Okay, so now that we've seen all 9 circle theorems, I'll work through a few examples with you so you can see them in action. Example 1. S and T are points on the circumference of a circle, centered O. PT is a tangent to the circle, and SOP is a straight line. We're told that angle OPT is 32 degrees, and we're asked to find the size of the angle marked X. Each stage of our answer is going to require a reason. That's really important to give reasons as you go along. Where to start? So I'd recommend looking at the diagram and just labeling on anything you can notice straight away. So for example, we know that PT is a tangent. So one of the first circle theorems said that a tangent and a radius meet at 90 degrees. We can label that as 90 degrees. And anytime we label something on, let's put our reason down as well. This one will be tangent and radius meet at 90 degrees. From there, I'm now seeing that we've got a triangle, and we know that angles in a triangle always add up to 180. So we can find that third angle there by doing 180, take away 32, take away 90. 180, take away 32, take away 90. That will give us 58 degrees. And our reason is angles in a triangle add up to 180. Okay, so that's 58. Another fact that we know is that angles on a straight line add up to 180 also. So you can find that missing angle there to be 122 degrees. And again, your reason is angles on a straight line add up to 180. And now we're getting closer to finding x. If we look at that other triangle there, I'm noticing that these two are the radii, and therefore that's going to form a nice isosceles triangle. So this angle will also be x, equal to the other base angle in the isosceles. From here, it's just a case of working with angles in a triangle again, but don't forget to label your reasoning. So we can say here, two radii form an isosceles triangle. And now we can just do 180, take away 122, and that gives us 58. And then we've got to share that 58 equally amongst the two x's, so let's divide that by 2, 29. So x equals 29 degrees. Example 2, so another circle with a bunch of missing angles. On this example, we're told that A, B, C, and D are points on the circumference of a circle, centre O, and angle BAD is 52 degrees. First of all, they want us to work out angle X. That one is going to be 104 degrees. And the reason is angles at the centre are twice the angle at the circumference. That's just one of the circle theorems being applied there directly. Now, in terms of angle Y, that one is opposite the 52, and it's opposite inside a cyclic quadrilateral. So those two will add up to 180, meaning Y is going to be 128. Reason being, opposite angles in a cyclic quadrilateral add up to 180. Lots of writing in this topic, but not so bad. Example 3, P, M, and S are points on a circle centre O again. RST is a tangent, PSO is 48, and MP is equal to MS. We want to work out the size of angle MST. I would label that on MST. That's going to be X. That's what we're looking for. And again, we got to give reasons for each stage of our working. When I'm looking at this diagram, again, the first thing I'm noticing is tangent and radius meeting at 90 degrees. So I'm going to pop that on there. Tangent and radius meet at 90 degrees, which will allow me to find that missing angle there. 90 take away 48 gives us 42. It may or may not come in handy later, but it's worth just labeling it on if you see it. Now, I'm also noticing that we've got a tangent and a triangle coming off that tangent. So if you remember, that's what I was talking about when we were looking at the alternate segment theorem. And that tells us that this angle is 42, but that means this angle up here is also 42 by the alternate segment theorem. A piece of information that we haven't used yet is the fact that MP is equal to MS. We're shown that with the lines there as well, meaning we've got an isosceles triangle once again. So this angle will be equal to this angle. We can find those two angles by just doing angles inside a triangle again. So let's do 180 take away 42. Which gives us 138. And then splitting that 138 equally between the two base angles would be 138 divided by 2, which is 69. Okay, so that's 69, and so is that. Finally, now we can actually apply the alternate segment theorem again, because this angle will be equal to this angle, and that's the one we want. We want x. So we can say x equals 69 degrees by the alternate segment theorem. And we're finished. Now, if you didn't see the alternate segment theorem, that's okay. Quite often there are different ways of getting to the same answer. So alternatively, what you could have done is notice that all of those bottom angles are on a straight line together. I'll put an alternative here. So, or we could do x equals 180, take away 42, take away 69. And either way, you're going to end up with 69 degrees. And for that reason, you would say angles on a straight line add up to 180. That's it for now. If you found this video useful, please remember to like, comment, and subscribe to my channel if you haven't already. And please do share this with anyone else who you think might find it helpful. Thanks, and see you next time.